Okay, so in this video, let's discuss about one of the most brittle component of any system, that is databases. So a database is one of the critical component of any system because at the end of the day, everything we build ultimately revolves around the data, right? So you can think about it like if Google loses its entire web search index, then the search index itself doesn't exist, right? Or if a bank loses all its customer data, the banking system simply wouldn't exist, right? So that's how fundamental databases are. So when we think about a system design, understanding and designing the database properly becomes most important or extremely important, right? So now we'll broadly classify the database into two, that is first is relational database and another one is non-relational database. So in this video, let's deeply discuss around the relational databases. Okay, so let's discuss about the relational databases. So in relational database, the data is stored in rows and columns and they are best known for the ACID properties. But the question here is, why was these ACID properties were introduced in this relational database? Or what was the problems the engineers were trying to solve with the ACID properties in the relational database? So the answer for this lies in the early financial systems like ledgers and banking records. So these systems had a requirement where the data needs to be atomic, consistent, and the transactions should be isolated, and overall the data should be durable. So all these needs led to the introduction of the ACID properties, which became the foundation of the relational databases. Now, let's understand each of these ACID properties in detail. Okay, so now first let's look at the first property, that is atomicity. So with the atomicity, we mean that every transaction is guaranteed to be fully completed or fully rolled back. So this to understand this theoretically, it's very easy, right? But how is it practically implemented inside the database? So for that, the database use something called as write ahead log. So what happens when we start the transaction? Let's say we have this transaction to be completed, and in this transaction we have two steps. The first step is to deduct the balance from the account A and then update the balance in the account B. Okay, so only when these two steps are completed, we can assure that the transaction is completed. So this is exactly what will be implemented inside the engine. So once when the transaction starts, it will maintain a log where it will keep on adding all these steps inside the log. So let's say it will first start the transaction. It will just add that in the log, like transaction has started. Then it will implement this step and it will check whether it is successful or not. Then it will just update that it is successful. And then it will implement the second step. Then it will update a second update as successful. And then finally it will commit and that it will just update it. So only when the steps has reached till the commit, then only actually the data will get updated on the disk. Until that, it is just updated in the log or in the memory. Okay, so once all the steps are completed successfully, then only the transaction gets completed and the data gets updated in the actual disk. But now let's take a negative scenario where the first step is properly completed and it will update as transaction started, and then the second step also completed, it will just update as completed. But now let's say this second step or the third step gets failed. Okay, so now in this case what will happen? It will update the log as failed and this commit will not get executed. So now once this transaction is completed and it will check the logs, it will see that there is no commit. It has only started but it has not committed. So once this happens, then it will automatically roll back. The engine will roll back the step 1 which was completed. So due to this reason, if a transaction fails, then the actual data will not get updated. So it will automatically get rolled back. So this write ahead log makes sure that the atomicity is achieved. And this also helps if the database get crashed. So even if in the middle of the steps, if the database gets crashed, the logs has the information of till which step the database was active, or till which step the transaction has been completed. So once the database comes back, it will first check the logs and then it will just update the actual memory, and then further transactions will get started. Okay, so now let's look at a demo of this. Okay, so let's understand the atomicity with this demo. So here let me first create a database like Atomicity demo. Then let's use this database. And in this database, let me create a table that is account, having the columns like ID, name, balance. And on the balance column, we have applied a constraint, that is a check, that balance should be always either greater than or equal to 0. So let me run this. Okay, so the balance table has been account table has been created. Next, let's insert some value and then let's check the table. We have this table and the values inside this. Next, now let's first see a positive scenario where we will execute a transaction where first we are deducting an amount from account 1 and adding that amount to the another account 2. Okay, so once we run this completely, so it will run as a single step where it will first start the transaction, it will update account 1, then update account 2, and then it will commit the transaction. So once we run this, we will see that the transaction has taken into effect, and now the Alice has 500 and Bob has 1500. Now this is fine. So this was a positive scenario. Now let's look at a negative scenario where we will explicitly fail a transaction, and then we will check whether the atomicity or the rollback will happen automatically or not. So now in this case, if I run this whole transaction as one single command, then it will not work on the MySQL workbench, because once this line 28 gets executed, then it will not execute further and this rollback will not be called, where I need to run each of them as a single command. So first let me start with the transaction, and now let me run this. So the moment I run this, and now if I check the account, you can see that Alice account balance has been reduced to 0. Okay. Now when I run this, it will fail because of the out of range value for column balance. Okay. So now this has failed. Now ideally what should happen according to Atomicity? The first statement which got executed and now the balance is 0, it should get rolled back. So for that reason, now I need to run this rollback. So now, but if you have observed, if you see here, it has already updated the database. But now if I roll this back, and now if I check the account, we can see that the statement got automatically rolled back, and now the Alice bank account has been rolled back to the initial amount. So this is what the concept of atomicity in the SQL databases.